So let's look at a couple types of continuity, or discontinuities. Piece of paper here. So, types of discontinuities. So the first one, let's look at f of x equals x squared minus 1 all over x minus 1. So here we have a rational function. And if we were to sketch this out, we have 1, 2, 1. So we have 1, 2, 1, negative 1. And this thing would look something like this. All right. Okay, so depending on, if you're in my class for pre-calc, or if you were in another teacher's class that stated this way, we would call this a hole. And that was fine back in pre-calc, but now we have to be a little bit more specific. And because we have our definition of continuity and we have the concept of the continuity at a point, we're no longer going to call this a hole. So from this point on, we're going to call this a removable discontinuity. Some of you might be asking, well, why didn't we call it a removable discontinuity from the get-go? And a lot of times when we're teaching, leading up to calculus, we can't be super exact, because as you'll notice that if we're exact with certain things, say in Algebra 1 or Algebra 2, it gets so complicated, it's hard for students to understand. So the same thing happened here. I called it a hole just because we needed something. I think I've read it in books too, but really it's a removable discontinuity. That's what this is. And so from calculus on, you now can say, oh, that's just a removable discontinuity. Right now, one thing about, and the reason we call it a removable discontinuity is because we were able to just take that point, you remove the point, and there we have it. Okay, now the neat thing about a removable discontinuity is there is a fix for a removable discontinuity. We just have to define the function at the discontinuity. So if we wanted to fix this, we would write f of x equals, and then we're going to have to use a piecewise defined function. And so we still have x squared minus 1 all over x minus 1 when x does not equal 1. And then we just got to figure out, well, what does this equal when we are at 1? And it's 2. So we'll say it equals 2 at x equals 1. And there we go. By just adding this second line, we're able to basically put a point in that removable discontinuity, and now we have a continuous function. So if we have a removable discontinuity, you can fix it, and fixing it requires that you make a piecewise defined function and put in a point at that removable discontinuity. Okay, next one. We have f of x equals the absolute value of x over x. So this is a good example. So what this one looks like is, in the negative side, we come up and that's negative 1. And then from 1, it goes on. So on the negative side, we're always at negative 1, and all of a sudden at 0, we just hop up here, and we're always at 1. And at 0, well, you can't divide by 0, it'd be 0 over 0, so that's indeterminate. So there are no values there. And when we just kind of hop up, we actually call it a jump. And so this is a jump discontinuity. And this one has no fix. There's nothing we can do to make this continuous. It's not like you can connect these two, because then we would no longer have a function, so that's not allowed. So there's no fix. Let's look at another one. This one you guys have seen before in previous classes. 1 over x squared, or something like this. Okay, so in this case, this function looks something like this. And so what we end up having is a vertical asymptote here. And you can't put in 0. Again, 1 divided by 0 is undefined, so that's not allowed. And so what happens with this vertical asymptote is these values keep on getting closer and closer and closer and closer to 0, but they actually never get to 0. So we call this an infinite discontinuity. Okay. And this one also has no fix. I mean, some of you might be thinking, well, can't we just somehow, these keep on going up and they get so close, can't we just kind of top it off? But there's nowhere to top it off because they keep on going and going. So that doesn't work. And there's one more. So we have the sine of 1 over x, and this one is a interesting graph. We don't spend a lot of time with it, but I just wanted to kind of be thorough with this list. What happens is you have your sine function coming in. And all of a sudden we get to this point here and it starts oscillating up and down. And then it kind of comes out. And then what happens is what's happening at x equals 0. I guess I should have added some more over here, but anyways. And notice that if you put in a 0, it's undefined. And as we get closer and closer to the 0, this 1 over x creates higher and higher and higher values. So this sine starts going, it starts oscillating back and forth between 1 and -1. And so we call this an oscillating discontinuity. And this one also has no fix. So of course, most of these discontinuities you can't so-called fix except for the removable discontinuity. But these are things that could come up. We'll definitely run into the removable. We'll definitely see the infinite discontinuity because we work with rational functions. The jump and the oscillating, that's probably not going to come up really in this class, but I just wanted to kind of make a complete list of discontinuities just so you have them in your notes.